Hey buddy, welcome to Datatastic. In today's video, I'm going to introduce you to logical operators in the programming language R. Logical operators are essential in almost any programming language, and in the end they all come back to basic math, so things you have probably worked with in the past, like comparisons like smaller or equal, greater or equal, not, and, or. So these are the basic logical operators, and let me show you a few examples in R. So for example, we could say something very simple like 5 is smaller than 3, and if we run this line of code down here in the console, we get the result. In this case, it's obviously false. So that's a false statement. We can also go ahead and say 5 is smaller than 5, which is false again. But we also have the option to say something like 5 is smaller or equal to 5. In this case, we basically add an equal sign. And this is of course true because 5 equals 5. And pay attention that the equal signs always come behind the smaller or greater operator. So if I would say 5 equals or is smaller than 5, then we would get an error. So always pay attention to the correct order. Next, we can of course also compare decimal numbers to integers. So we could say 3.5 is greater than 2. And of course, that's a true statement. Next, we can also do, for example, 4 is equal to 4. It's very important that you use two equal signs, because if you would say 4 and then one equal sign 4, then R tries to assign the value on the right to whatever is on the left. So that would be a variable assignment, and of course that's not what we want to do. So always use two equal signs to compare for equality. So for example, you could also say 2 plus 7 equals 9. And this of course gives us true as well. But if we would say 2 plus 7 equals 9.01, then of course it would be false. But 2 plus 7 equals 9.000 is again true. So we can compare integer values to decimal numbers, and if they have in the end the same value, we also get a true. We could also, for example, say 10 plus 2 is greater than 8. We can also group this expression to make it a bit more obvious. But of course, we can also use logical operators when working with variables. And in fact, if you program something, then you almost always do these types of comparisons with variables. So for example, we can have a variable age, and let's just assign the value 21. And now we could, for example, say age is greater or equal to 18. So that's a practical application if we want to check if the person is an adult. And we would get the value true because 21 is in fact greater or equal to 18. Another thing we could do is, I've already showed you the equal operator. So for example, age equals 15, which is false. But we could also say age does not equal 15. So we put an exclamation mark in front of the equal sign. And now we get the value true because 21 is in fact not 15. We can also do the same thing with numbers, so without using a variable. For example, 6 does not equal 6, which is of course false. We can also create a new variable and we can assign a true or false value to this variable by, for example, saying age, which is our variable from up here, age is greater or equal than 18, and we can print the value in isAdult, and it's the value true. But we could also change the value for age, so let's say 12, and then of course isAdult takes on the value false. Another very important operator is the not operator. So for example, as I've shown you, isAdult contains the value false right now. We can also see it up here. But if we put an exclamation mark in front of the variable and we print it, we get the value true. So a false becomes a true and a true becomes a false. But pay attention that the value of the variable is still false. But when we go ahead and print it, then R sees, okay, it's a false value in this variable, and then R sees the exclamation mark and therefore turns the false into a true, but only for this statement. So we don't save this as a new value. However, we could do it. So we could say isAdult equals isAdult. And now you can see we've just flipped the value in the variable. Two more very important operators are the AND operator and the OR operator. For example, we could say 5 is greater than 2, which is of course a true statement. And then we can say OR, so use this pipe character, or 9 is greater than 12. And we still get the value 2 because the first statement was true, the second one is false. And if we have a true and a false statement and we use the OR symbol or the OR operator, then we still get a true value. But we could do the same thing. For example, we could go ahead again, 5 is greater than 2 and 9 is greater than 12, and this would give us false because in this example, again, the first statement is true, the second one is false, and true and false equals false. Lastly, we have the XOR operator. So we use this as a sort of function call and we have to pass X and Y. And XOR basically means that either one or the other, but not both. So, for example, we could, let's again say 5 is greater than 2, which is a true expression. And then we could say, again, 9 is greater than 12. And pay attention that we use a comma in between and not any other symbol. So in this case, we get the value true because it's either one or the other, but not both. So in this case, one is true, the other one is not. So the XOR operator gives us a true value. However, if we would do the same thing again, 5 is greater than 2 and 7 is greater than 2, then we would get false because no, both are true. And that's not either one or the other. It is in fact both. But when both are the same value, so both are either true or both are false, then the XOR expression turns into false as well. So we can also actually add the word true, so true and true is false. False and false is also false. but true and false is true. And of course the other way around, false and true is also true, because now it's one or the other, but not both. We can also use a bit more complicated expressions. So for example, we could say 9 times 2 is greater than 10, and 4 does not equal 5, or let's just say 5 does not equal 5. So right here we have 9 times 2 is 18, it's greater than 10. So therefore right here we have a true expression, but 5 does not equal 5 is of course false. So we've got true, false, which gives us true. But when I change it back to 4 does not equal 5, we get a value of false for the XOR statement, because 4 does not equal 5 is a true statement, and therefore we have two truths giving us a false. So when do we need logical operators when programming? Usually we use them for control flow statements. So for example, for if statements, or different types of loops. But we can also use them, for example, to access data that is stored in a data frame or a data table, or even a vector. So we can use them to access elements in a data structure. So for example, when we want to access elements in a data structure, we could write an expression such as age is greater or equal to 18. And then if we have a data frame or data table that contains people including their age, then we would only access those where the expression age is greater than or equal to 18 is true. Or to make a very simple if statement as an example right now, remember we have the variable age, currently the value is 12, but we could say if age is greater or equal than 18, we could print person is an adult, and we did not print it because the value is 12, and so we could add an else statement as well. Person is not an adult, and we get the result person is not an adult because the value is 12 inside the variable. But we could also change it up here. We could say person is 22, and now it says person is an adult. So that's a very easy application of a logical operator. Alright, so that's it for today. I hope this video was helpful. If it was, feel free to like, and if you are interested in more tutorials about R and RStudio, then feel free to subscribe, and see you in the next video. Bye.